Hello and welcome to Apex Math. Today we are going to look at how to solve rational exponent equations. A rational exponent is an exponent that's a rational number, and a rational number is something that can be written as a fraction. So basically we're going to look at solving equations that have fractional exponents. So we're going to start off with an easy one. So let's say we have x to the 3/2 equals 27. So this here is a rational exponent because it's a fraction. Now solving equations with rational exponents is actually pretty easy. The goal is to isolate your x. So right now our x is already isolated. We don't have any other stuff here except x to a power. Now, if there had been a +1 or something else, just like as if I was solving 2x plus 1 equals 9, what I do is, in this case, is I leave this till the end, and I would have subtracted 1 first, and then I would take care of the thing that's attached to the x at the end, and I would divide by 2 as my last step. But in this case, we don't have any extra stuff. So we can go right ahead to addressing the fact that we have x to this power. So our goal is to end up with x equals a number. So what that means is we want this to go away. So how do we make this go away? Well, we make it go away, we've talked about this a lot, is we use the inverse. The inverse of a fraction is its reciprocal, or the flip-flop of the fraction. So what we're going to do is we're going to raise both sides to the power of the reciprocal here. So if we have x to the 3/2 equals 27, the way we're going to handle that, to make that 3/2 go away, we're going to raise it to the 2/3, because that is the reciprocal of 3/2. What we do to one side of the equation, we must also do to the other side of the equation. So since I use the inverse here, if you multiply, and you don't actually have to do this each time, but just to show you that because these are inverses of each other, this gives you 6/6, which is equal to 1. So this becomes x to the first power, which is just plain old x. So these cross each other off, which gives us our goal, which is just to have x by itself. So now all I have to do is evaluate 27 to the 2/3 power. So how do I do that? Well, I could punch it into my calculator, but in case you're given a test where you don't have a calculator at your disposal, let's talk about how to do it without our calculator. Remember that when you have a rational exponent, the top is the power, and the bottom is the root. And I always look first to see if the root is a perfect root. So in other words, can I take the cube root, because that's what this is, it's a 3 root, so it's a cube root of 27, and does that give me back a regular number, an integer, or a whole number? So if I take the cube root of 27, I am asking myself, the cube root of 27, I am asking myself, what times itself 3 times gives me 27? So blank times blank times blank equals 27. What number times itself 3 times gives me 27? That's what a cube root means. So 27 is a pretty small number. So if you don't know off the top of your head, you can just start with 2. Well, 2 times 2 times 2, that would 2 times 2 is 4, times 2 is 8, so that doesn't work. So let's try 3 times 3 times 3. Well, 3 times 3 is 9, and 9 times 3 is 27, so that works. So the cube root of 27 is equal to 3. So I basically can reduce this and this piece down to 3, and all I'm left with now is the power. So I end up with 3, and the power is 2, 3 squared, which then is easy to do, so the answer becomes 9. So the solution to this is x equals 9. So let's try one that's a little bit harder now. Let's do 26 equals -1 plus 27x to the 3/4. Now we talked a minute ago about the fact that when we're solving for x, and I've used this term in the past, the term sticky, is that when there's things attached to that x, that's sticky, and we deal with sticky things at the very end. So I want to get rid of the things that are not sticky first. So I'm going to leave that alone, and this is what I have to take care of first, because that is very far away from my x. So I'm going to get rid of this -1 first. So I'm going to do +1. So I'm going to +1 to both sides, and I get 27. That crosses off, and now I have 27x to the 3/4. So now I have something to a fractional or rational exponent. So I need, in order to be able to get to this x, I need this ugly thing to go away. So how do I make it go away? So anytime you don't like something, say to yourself, how do I make it go away? Well, you use the inverse. That's how we make things go away. And the inverse of 3/4 is 4/3. So I'm going to raise both of these to the 4/3 power. So I'm going to do 4/3 over here, and I'm going to do 4/3 over here. Now the 4/3 and the 3/4 just cross each other off. So that makes that go away, and I'm left with just 27x. Now I have to evaluate 27 to the 4/3. 27 to the 4/3. Now remember that the top number is the power, and the bottom number is the root. And we already established in the last problem that if we take the cube root, and we always look to that root first to see if we can do that, the cube root of 27, we already said, is 3. So this piece reduces to 3, so I just have a 3 to the 4th. So now I want to divide by 27 to solve for x. So I divide by 27. Now I can do this out longhand, but a shortcut to doing this would be, I know that 27, I've just established that 27 is, I have 3 to the 4th on top, and I know that 27 is 3 to the 3rd power. So if I rewrite this as 3 to the 4th over 3 to the 3rd, then I can say, well, that's 3 times 3 times 3 times 3 over 3 times 3 times 3. Each of these 3's cross off, and I just get 1 3 as an answer. Or you could subtract your exponents. 4 minus 3 is 1, so I end up with 3 to the 1st power, or 3. So again, if you don't have a calculator, it's a lot easier to do that than to multiply out 3 to the 4th and then divide by 27. Just recognize the fact that 27 is a power of 3, and then you can use this little trick to make it go faster if you don't have a calculator available. All right, so let's take a look at another problem here. Let's say we have 4b to the negative 3/4 plus 10 equals 21 over 2. So again, if I look at what is sticky here, well, the thing that's furthest away from my variable is this guy right here. So I want to get rid of him first. So I'm going to subtract 10 from both sides. Well, if I do 21 over 2 minus 10, this is a fraction, so I'm going to have to find a common denominator. So finding a common denominator here is pretty easy. If I have 10 and I want to convert that to something over 2, I have 10 over 1. I would multiply the top and the bottom by 2, so I get 20 over 2. So I can do 21 over 2 minus 20 over 2, and that gives me 1 over 2, or 1/2. So now I have 4b to the minus 3/4 equals 1/2. So the next thing, if I look at, again, the b is what I'm solving for. So the next thing that I want to make go away is the 4. And since it's multiplied times the b, the inverse operation would be divide. So I would divide by 4 on both sides. That crosses that off. And I have 1/2 divided by 4. Well, if I divide, it means I invert and multiply. So I have 1/2 times 1/4, which is 1/8. So now I have b to the minus 3/4 equals 1 over 8. Let's get ourselves some room up here. So we can see here that we have a negative exponent. And remember that a negative exponent just means that we're dealing with the opposite location of the, in terms of a fraction, instead of being in the numerator, we're looking at the value that is in the denominator. So I can rewrite this, since it's 1 over the number. Remember that x to the negative 1 is 1 over x. So if I have 8 to the negative 1, that's 1 over 8. So the shortcut here is to just say, well, this negative is going to cancel out the fact that I have a fraction here. So I can just say b to the positive 3/4 is equal to 8. So getting rid of this negative exponent moves the 8 from the denominator into the numerator. So that's how we work with negative exponents. So that's the easiest way to take care of that negative exponent, is to simply move that 8 from the denominator into the numerator. And now I simply use the inverse. Again, I want to solve for b, so I want to make this 3/4 go away. So to make it go away, I multiply by 4/3. Raise it to the 4/3 power. And what I do to one side, I do to the other. That crosses each other off. And now I need to find the value of 8 to the 4/3. So 8 to the 4/3. So I always look first to the root. Can I take a cube root of 8 and get back a whole number? Well, yes. What times itself gives me 3 times, gives me 8. Well, it's 2, so the cube root of 8 is 2. So this becomes just a 2, so I have 2 to the 4th. And you can do that out if you want. 2 to the 4th. 2 times 2 is 4, times 2 is 8, times 2 is 16. So that becomes our final answer. All right, let's do one last problem here. Let's do -3 plus 8 minus 2x to the 5/4 equals 29. Now you might want to go ahead and pause the tape, the video at this point in time, and see if you can do this on your own, and then come back and you can check and see if you did it right. All right, so the first thing you should have noticed is the thing that's furthest away from the x is this guy. So that's the guy we're going to get rid of first. So we're going to do the inverse operation. We're going to add 3 to both sides. So if we add 3 to both sides, we get 8 minus 2x to the 5/4 equals 32. Now we need this rational exponent to go away. So we're going to use the inverse. We're going to multiply by 4/5 raised to the 4/5 power. We're going to raise to the 4/5 power on this side as well. That crosses itself off. So we have 8 minus 2x equals, and now we have to figure out 32 to the 4/5. So again, root power. So first we look at the root. Can we take the 5th root of 32? That's a really small number. So if you check it, 2 is going to work. So now I have 2, so this just becomes a 2, so I have 2 to the 4th power. So 2 to the 4th. And we already established that 2 to the 4th is equal to 16. So now we just have a very simple level 1 algebraic problem to solve. We have 8 minus 2x equals 16. So the first thing we do is subtract 8. So we have negative 2x equals 8. We divide by negative 2. And x is equal to negative 4. So, the things to remember when solving equations with rational exponents is to get rid of the things that are the farthest away first. So the things that are the farthest away go first. Remember to raise both sides to the inverse or the reciprocal of your rational exponent. Raise both sides to reciprocal. Remember that when you have a rational exponent, that the bottom number is your root and the top number is your power. And other than that, it's really not that hard to solve these types of equations. The biggest thing is to don't skip steps. That's how you make careless mistakes. And I know a lot of people just don't want to bother to write it out, but it really makes a difference if you don't skip your steps and you write out each step. Organization and going slow is the key to getting these problems done easily and quickly. I hope this video was helpful in helping you understand how to work with rational exponents equations. Thank you for visiting us at Apex Math. Please remember to like our videos, and any additional comments on future videos that you'd like to see, we'd be happy to provide those for you.